Good morning. Myself, Dr. Maheswara Rao, lecturer, Department of Civil Engineering, Institute of Aeronautical. Our course name is Fluid Mechanics and the topic name is Combination of Fluid Flows. So before going to the topic, the course outcomes. The course outcome means the end of the course, the student will be able to give the solutions or get the knowledge. Those are called course outcomes. So now the course outcome one is the students can define the fluids and their properties. So they can describe the surface tension and relations in different conditions. So these definition of fluids and properties, surface tension. So they will come under the course outcome one. And course outcome two is the classification of fluids based on the Newton's law of viscosity. So that means fluids are classified based on the Newton's law of viscosity. So if they obey the Newton's law of viscosity, they are called Newtonian fluids. If the fluids are not obeying the Newton's law of viscosity, they are called non-Newtonian fluids. And some problems in the viscosity. So they are course outcome 2. So course outcome 3 is the capillary rise or fall. That means whenever you insert a smaller diameter tube in a fluid, some fluids will rise inside the smaller diameter tube. Those are called capillary rise. And some fluids will lower its level in the smaller diameter tube. They are called capillary fall. So this capillary rise, capillary fall is coming under course outcome 3. Course outcome 4 is the surface tension. So what are the concepts of surface tension and their applications? So that is the course outcome 4. And course outcome 5 is the compressibility. So that means a fluid can change their volume by the application of external forces. That is called a compressibility. So some fluids are compressible fluids, some fluids are incompressible fluids. So example, gases. So if you apply external forces, so its volume can be changed. Those are called, that means gases are called compressible fluids. So whereas water, if you apply external forces, it will not change their volume. So they are called incompressible fluids. Here, both the volume, density also will change. So if the change in density or change in volume, they are called compressible fluids. If there is no change in the volume or if there is no change in density, they are called the incompressible fluids. So example for the compressible fluids is gas. Example for the compressible fluids is gas. Incompressible fluid is water. So course outcome 6 is the pipe flow or frictional losses. That means whenever a fluid is flowing inside the pipe, so inner surface of the pipe material and the surface of that fluid will have frictional forces while traveling, while moving. So from one point to another point, if a fluid is flowing, so there will be frictional losses. So that means energy loss will happen. So those basic concepts, ideas of pipe flow, fluid friction, fluid pressure, and head at different nodes of the pipe network, they are coming under the course outcome 6. Combination of fluids. Today's topic is combination of fluids. What is the combination of fluid flows means? Flows means a fluid is moving anywhere. So fluid flows means fluid is moving. Fluid are flowing. So they are having independently, they are steady flow, uniform flow, unsteady flow, non-uniform. So those we discussed with this class. What is the steady flow? So if you see the velocity of a fluid at any point, at any time, so at a particular point at any time, your velocity is not changing. So if you take a particular point A, So if you see the velocity now, if you see the velocity after some time, if you see the after some time also they are getting same velocity. They are called steady flow. Unsteady flow means if you take a point A, the velocity now at point A, the fluid is having different velocity, and some other time at the same point A, the velocity is different again. So they are called unsteady flow. So there is uniform flow and non-uniform. Uniform flow means if the velocity is same at all points at a particular time. So the difference between steady and uniform will be at different timings. If it is same, velocity is same, that is steady. At same time at different points, velocity is same, that is called uniform. So a circular constant diameter pipe can have a uniform. So non-uniform flow means at different points it is having different velocities at a particular point of time. Those are called non-uniform flow. That means if the pipe is varying diameter, then the velocity at each and every point is different because the area is reducing or enlarging. So the velocity at different points is not the same at a particular point of time. That is the non-uniform flow. Now, today's section is this combination of flows. Combination means you can combine steady and uniform, steady and non-uniform, unsteady, uniform, unsteady, non-uniform. So they are the combination of different flows. So with respect to time, the steady flow. With respect to space, is the uniform. A combination of time and space. There now combinations we will discuss. So if you see first one, steady uniform. So what is the definition given here? A flow where the fluid properties like velocity, pressure, density are constant with respect to both time and space. Okay. So here the definition of both the flows are given. A steady flow definition and uniform. So steady flow means what? It is nothing but at any point of time, at a particular point A, the velocity is same. What is the definition for the uniform flow? At all points, at any point, at a particular point of time, velocity is same. So the combination of steady and uniform flow means at any point of time, at any point of the space. So both the velocity is not changed. So that means if you see A, B, C, D points, the velocities now also same velocity, after some time also same velocity, and also velocity at A is equal to velocity at B, velocity at B is equal to velocity at C. So that is, if you take a flow here, if it is take a A point, B point, C point, D point. Okay. So you can measure both the velocities of VA is equal to VB is equal to VC. So this is the uniform flow. And if you see the velocity at VA at a point of time, okay, T1 is equal to VA T2 at different time. That is equal to VA T3. So at different times the velocity is same. That is steady flow. So it is a combination. So different points, same velocity, different timings also, same velocity. So that is the steady uniform flow. So here, what is given here? Velocity, pressure, and density. So these three properties are same. So velocity is same, different points, different timings. Pressure is same at different points and different timings. So here, the velocity, pressure and densities are constant with respect to both time and space. So they are called steady uniform flow. So now see the characteristics. What are the characteristics are here? Velocity and other properties do not change over time. So maybe velocity or other pressure, density or those properties do not change over time. So that means at any time these properties are same. at any point in the fluid. And next characteristic is the properties are also same at every point along the flow direction. So not only at different timings, but also at different points in a flow. So both these velocities and other properties are same. These are the characteristics of steady uniform flow. Example, if you see the example for the steady and uniform flow. So water flowing at a constant rate through a straight pipe. So what we need for the different points, we have same velocity. So that means straight pipe. So it is not a curved pipe, it is not a varying pipe. We take constant diameter. So whatever the diameter here, same diameter will be there everywhere. So if the diameter is same, then the velocity is same at any point, at all points. So, and the rate of flow is constant. So then we'll have uniform velocity. In this scenario, velocity of the water remains constant at every point in the pipe, does not change with time. And also, these will not change with respect to time also. So with respect to space also, they are not changing. With respect to time also. So now if you see the same velocity, after some time same velocity, and after some time also, we will have same velocity. So that is the example of the steady uniform and steady non-uniform. So here, steady means what? At any point of time, the velocity is same at a point A. Here, non-uniform flow. That means at different points of the flow, the velocity is not constant. So uniform means velocity is constant. So if it is here in this figure, velocity is same, v. So that is uniform. So if the pipe is varying like this, different diameters, here is dia, here is dia, here is 2 times dia, it is dia, then here velocity is v1, here v2, here v3. So different points in flow, the velocity is changing. That is the non-uniform. But if you see this is point A, B, C. So if you see any point of time, now after some time also, at A point, velocity is always v1. Similarly at B point, if you see now velocity is v2, after some time also velocity v2. So velocity is not changing at B point over a period of time. Any point of time, velocity is not changing. But different points in the flow, that is the space, the velocity is changing. That's why this is steady non-uniform. Steady means different timings, the velocity is not changing. Non-uniform means at different points in a flow, velocity is different. So here is a velocity. Steady means velocity is same. Non-uniform means velocity is different. So here that I think is the time. Steady is the time. So with respect to time, at a point, velocity is same. But non-uniform flow means at different points A, B, C, velocity is not same. So that is the definition. So you see the definition here. A flow where the properties do not change with time, but vary along the flow direction in space. So flow is constant. So the flow is not changing. That means velocity is not changing with the time. But along the direction of flow in space, the velocity is changing. That is the steady non-uniform. So characteristics. So velocity is constant over a time at any given point, but it varies along the length of the flow. So example. So water flowing at a constant rate through a pipe that has a varying diameter. So here pipe is having a varying diameter. So here is a dia, 2 times dia, here it may be 1 time dia. So then this is happening. So example pipe that narrows or widens. So it may be narrows or widens also. Same but different diameters. Here while the flow rate remains steady over a time. So but the steady rate is same at a particular point of space at any time. The constant velocity is constant. So velocity changes depending upon the cross section area of the pipe at different points. So velocity is changing only at different points because the cross-sectional area is very. So that is the non-uniform. But at any time, at a particular point, velocity is not changed, even if it is a varying point. So at A point, if you see any time, velocity is constant. So let us take V1. At B point, if you see any point of time, the velocity is V2 at any point of time at B point, like that. An unsteady uniform. So here unsteady uniform. Unsteady means what? The velocity is changing with the time. So that means if time is changing, velocity is also changing. But uniform. Uniform flow means at different points of the flow, the velocity is constant. That is uniform. So with respect to space, velocity is constant. With respect to the time, velocity is not constant. So that is the unsteady uniform. Let us see the definition. A flow where the fluid properties are uniform in space but change over time. So with respect to space, velocity is same, or fluid properties are same but change over the time. So that is the unsteady uniform. So characteristics. Velocity is same at all points because it is uniform flow. Velocity is same at all points in the plane at a given time, but changes as time progresses. So at a given time, the velocity is same at all points, but over a period of time, the velocity is changing. So that is unsteady uniform. Example: the flow over straight pipe. So if you want uniform flow, what should we need? We need a constant diameter pipe. So straight pipe, that is being filled or emptied. So here thing is that filled or empty. So while filling or while emptying, so depending upon the time, the velocity is changed. But the velocity is same at all different points in a space because the pipe is straight pipe, same diameter pipe. Initially, flow velocity may increase or decrease uniformly across the pipe, but any given time, velocity is the same at all points along the pipe. So that is the unsteady uniform flow. Then unsteady non-uniform flow here. So the heading is unsteady non-uniform. Unsteady means what? The velocity is changing with respect to time. So if you see now, some velocity will be there. After some time, the velocity is different. After some time, velocity is different again. So at different timings, the velocity is different. That means velocity is changing with respect to time. That is called unsteady. And non-uniform. What is the non-uniform flow? The velocity at different points. That means the space at point A, point B, point C. So if it is a point A, it is a point B, it is a point C, point D. So like that, at different points of the flow, the velocity is also changing. So velocity is changing both with respect to time, velocity is changing. With respect to space also, velocity is changing. So then that is called unsteady non-uniform. So let us see the definition given here. A flow where the fluid properties change both with the time and space. So fluid properties are changing. So if you see with respect to time also, they are changing. With respect to space also, the fluid properties are changing. That is the definition for the unsteady non-uniform flow. So if you see the characteristics, so velocity and other properties vary from point to point. So velocity and other properties, that means density, pressure, those are the other properties. They vary from one point to another point in flow and also change over time also. So if you see at a particular point of time, velocity is different at different points. And also if you see the velocity at different timings also, velocities are different. So both with the different points at the same time, velocity is different, and at the same point at different timings also velocity is different. So that is the characteristics. Example, say a flow of water in a river. So if you see the water flow in a river, the speed changes due to obstacles, bends, or variations in the river bed. Okay. So if it is a river flowing, so because of the obstructions, that means if water is flowing like this, some store is there, okay, some obstruction is there, so water is flowing irregularly. That means no constant speed or bends. So if river is flowing like this, if it is a bend, water is flowing like this. So if there is a bend in the river portion, or if there is an obstacle in the flow, river flow, okay, in the river bed, so combined with changes in the flow rate over time. So here, flow rate over time. So that means with respect to time also velocity changes, with respect to space also velocity changes. Perhaps due to rainfall or snow melt. Because of the rainfall or snow melt, these velocities are different at different timings and different points. Here the velocity differs at different locations and changes over time. So at different locations, A location, B point, C point, D point, E point, at different locations, velocity is not constant, velocity is changing, and different timings. So now after 10 minutes, after 20 minutes, like that, at any different timings also velocity change. So then that is a unsteady, non-uniform. That means with respect to time also velocity is changing, with respect to space also velocity is changing. So that is called unsteady, non-uniform flow. So if you see the combination of fluid flows, so here it is given 4 types. So first one is steady uniform flow. Second is steady non-uniform flow, unsteady uniform flow, unsteady non-uniform flow. Here steady uniform flow means a calm, straight flowing river where every point has the same speed and direction consistently over time. Okay, it is also a river flow, but the water is flowing at a constant rate, okay, consistently over time. So if you see now, after some time also, we are having same rate of flow. Okay, so a calm and a straight flowing river, so where every point has the same speed and direction, so consistent over time. That is the steady uniform. So whereas the steady non-uniform, so here the same river but with varying widths. So if width is varying, depth is varying, so that means what is that? It is nothing but a varying diameter of pipe. In case of pipe flow, varying the diameter is changing. Here also river width is changing, reducing or widening, or depth is also changing, low depth, higher depth, like that. So because of this width-wise changing and depth-wise changing, so there will not be the same velocity at different points, say for different locations. But at a particular point, the velocity is same at any time. So that is steady non-uniform flow. So here, steady non-uniform flow, the same river but with varying widths and depths, causing the speed to change at different points, though still steady over time. So velocity is not changing over time, but it is changing over the space, different locations. That is the steady non-uniform. So another one is unsteady uniform. So a straight river where the flow speed increases gradually at all points simultaneously, perhaps due to opening the dam upstream. So if dam upstream it is open, okay, it is a dam. So if these gates are open, then flow will come. Okay, a straight river. The river is a straight portion where the flow speed increases gradually because gates are open, dam gates. So water speed increases gradually at all points simultaneously. Okay, so that is a unsteady uniform flow because the gradually speed increasing. That means if you see the speed now after some time, with respect to time, the velocity is increasing. That means changing the velocity. That's why it is unsteady flow. But at different points of locations, the velocity is constant. So that is the uniform. So that is the example for the unsteady uniform. The last one is unsteady non-uniform flow. Unsteady non-uniform. So a river, that means with respect to time, velocity is not same. With respect to location, space, also velocity is not constant. See, a river with varying depths. So non-uniform flow means what? It is varying widths or depths and obstacles, where the speed fluctuates not just along the river but also changes over time due to, say, changing weather conditions. Okay, here, because of the changing weather conditions, unsteady flow will come, and because of the change in the widths and depths of the river, non-uniform. So that is the unsteady non-uniform flow. So if you see, review once combinations of fluids, okay, steady uniform flow is one combination. So that means the velocity and other properties are same at any time and also at any location. That is the steady and uniform flow. And steady and non-uniform flow. Velocity is same at any point of time, but at different locations, velocity is not same. Then unsteady uniform flow. So velocity is changing with respect to time, but velocity at all different points are same. So that is the unsteady uniform flow. Unsteady non-uniform. That means the velocity is changing with different points of time, and also velocity is changing with different locations of space. So that is the unsteady non-uniform flow. So like this steady uniform flow, that means velocity is same at different points of time and also different locations. And steady non-uniform flow, velocity is same at different points of time, but velocity is not constant at different locations or different. Unsteady uniform flow, that means velocity is changing with respect to time, but velocity at different locations is same. So unsteady non-uniform, that means velocity is different points of time and also different locations of space. So those are the unsteady non-uniform. So reference is K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw-Hill, Student 12, Modi PN and Sensei, Hydraulics and Fluid Mechanics, Standard Proposed 2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.